The following is an AZPM original production.
Arizona Science is supported by Research Corporation for Science Advancement.
For Arizona Public Media, I'm Tim Swindle, Professor Emeritus of Planetary Science at the University of Arizona, and this is Arizona Science. Joining me today is Shane Byrne, a professor in the university's Lunar and Planetary Laboratory and the principal investigator of the HiRISE instrument in orbit around Mars. Welcome, Shane.
Hi, Tim. Thanks for having me.
We got a question a little while back about whether Mars has seasons and how those work, and I thought you'd be the perfect person to ask since you study Mars, and in particular some of the seasonal changes. Does Mars have seasons?
Oh, it does. Remarkably similar seasons to the Earth, it turns out. And people have been observing these with telescopes from the Earth for a long time, watching polar caps come and go as Mars goes around the sun, and summer and winter flip hemispheres from north to south.
You say they're similar to the Earth. In what sense?
So you can think about how extreme a seasons get by how tilted over a planet is, a quantity that astronomers call obliquity. And Mars and the Earth share a similar kind of obliquity. So you get half of the year in darkness at the winter pole, and then you get half the year in sunlight when it comes summer. The amount of permanent darkness and permanent sunlight that you get is similar to the Earth because the tilt of the two planets is pretty similar.
On Earth, we know that when it's summer in the northern hemisphere, it's winter in the southern hemisphere and the other way around. And there are some differences at latitude because of ocean currents and things like that. Are the seasons from north and south similar on Mars?
They are a little different because the one thing that Mars has that Earth does not is an eccentric orbit around the sun, which means it's not quite a circle, and it's sometimes a year it's closer to the sun than at others. And it just so happens that at the moment, the summer in the northern hemisphere is further from the sun. So it's a little cooler in northern summer and a little warmer in southern summer.
How do you define New Year's on Mars?
We define the New Year's by having the year start at the equinox. And the numbering of the years is sort of random. One person came up with a scheme, someone called Todd Clancy, decades and decades ago, and started arbitrarily numbering Mars years starting in the 1950s with Mars Year 1. So we're up to Mars Year 38 now, I believe. The numbering scheme may be suspiciously linked to his birthday. That's never been actually definitively proven, but we somewhat semi-officially use that numbering scheme.
Are there New Year's celebrations for Mars?
Sometimes, yeah. And this year there was a group that got together online on a Zoom call to celebrate New Year's. But no fireworks, unfortunately.
You study the seasons on Mars with the HiRISE instrument. What is the HiRISE instrument?
Yeah, HiRISE is a great success story here at the University of Arizona. It is a high-resolution camera, and it's been in orbit around Mars since 2006.
What can you see in terms of seasonal changes with HiRISE?
A lot of interesting things. Mars is always cool because it's got this unique blend of the familiar and the exotic. So you can see layered ice caps at the poles that have climate records in them. That's much the same as what you would find in Greenland or Antarctica on the Earth. But we also see very exotic things. The seasonal caps are made of carbon dioxide ice, like dry ice. So they sublimate from the bottom up, and that pressurized carbon dioxide gas can explode outward in a fountain of dust and a jet of gas that creates little fans on the surface that we can...
Sort of like an avalanche?
More like a geyser, although it's not using the same materials as a terrestrial geyser, but you have a flat surface that's covered with ice, and then this like gas jet that's coming up from beneath the ice and entraining all sorts of debris inside it that's raining out around it.
And do you actually catch these things in process?
We have not yet. We see the after effects of these explosions and the gas jets, and we can explain it theoretically. And we've tried for years to see these things in progress. HiRISE is not at the best local time to see that. All of our images are in the afternoon, and we expect these things to be most active at noon when there's most of the sunlight.
Well, thanks for talking with us today, Shane, and good luck for the continued success of HiRISE, hopefully through many more Martian seasons.
Great, delighted.
Our guest today has been Shane Byrne, who studies the surface of Mars, and in particular, some of the seasonal changes that can be observed from orbit. This is Tim Swindle, and you have been listening to Arizona Science. You can also listen to this and other Arizona Science segments by going to the AZPM website at azpm.org.
Thank you to Research Corporation for Science Advancement for their support of Arizona Science. AZPM podcasts are made possible in part by donations from listeners like you. Learn more at support.azpm.org. Thank you.